All right, Mr. Buckle back with a couple of examples on systems of equations. This time we are going to solve the systems using substitution, as indicated by the big red letters right here. So we already solved some systems of equations by graphing. Now we're going to solve them using substitution, which you will find is a much more efficient method of solving a system. And once again, a system of equations are two equations where we want to find the coordinates, or the coordinate, xy coordinate, that satisfies both of the equations at the same time. So what x and y satisfies one equation and also satisfies the other one. So we have two equations here, y equals 5x minus 25 and y equals negative 8x plus 27. We're going to solve using substitution. And we know that y is equal to 5x minus 25. We also know that y is equal to negative 8x plus 27 because that is the system with which we are working. So what I can do here is take this 5x minus 25, and since this is equal to y, I can plug it in for this y here. Since this is equal to y, and these two are both y, I can just take this and plug it in to the bottom equation for y. And what I get when I do that is this equation. I get that 5x plus negative 25 is equal to negative 8x plus 27. These two things have to be equal because they are both equal to y. And since they're both equal to the same thing, these two must be equal also. And now what happens is we're in a position to where we can solve for x because there's only one variable now, and that variable is x. So we're going to use algebra to solve this equation, and then we will have our x coordinate for our solution. So if I just look at this equation here and want to solve this equation, what I'm going to do is separate the left side of the equal sign from the right side, and I'm going to do a couple things here. Looks like a lot of business going on. I added 8x to both sides. I want this minus 8x to go away. So I'm going to add 8x to the right-hand side. But if I add 8x to the right-hand side, I have to add 8x to the left-hand side. And notice how I line it up with the 5x because they are like terms. These two can be added together. 8x and negative 25 cannot. So I line the 8x up with the 5x. I also am going to add 25 to both sides. So I'm kind of moving my x's to the left-hand side of the equal sign, and I'm moving my constant, my numbers, to the right-hand side of the equation. So by getting rid of a negative 25, I'm going to add 25. Add 25 to this side, and therefore these two will go away. And then I add 25 to the right-hand side. So when I do all this addition, what I end up getting is the 25's cancel out. Negative 25 plus 25 is 0. The 8x's cancel out because negative 8x plus 8x is 0. And what I'm left with is 13x on the left-hand side because 5x plus 8x is 13x. And 27 plus 25 is 52. So now I have 13x equals 52. And if 13x equals 52, I can divide both sides by 13 and find that x equals 4 because 13 times 4 is equal to 52. So what this means is that our x coordinate of our solution is 4. I know that x has to be 4. And now that I know that x is 4, I can go back to our original equations here, y equals 5x minus 25 and y equals negative 8x plus 27, and plug in 4 for x because I have found that x needs to be 4. So I can plug it into either equation. It doesn't matter because it's a solution to both of them. And I'm going to find that x, or y, the y value will have to be negative 5 because if I do 5 times 4 is 20. 20 minus 25 is negative 5, which is our y value. If I move to the bottom one, negative 8 times 4 is 32. And 32 plus 27 is negative 5, right there. So our solution to the system is 4, negative 5. This is the coordinate that satisfies, these are the coordinates that satisfy both of these equations at the same time. Another example here where we have Rick, who has $290 and he's saving $5 a week, and Sophia has $200 and she's saving $8 a week. And we can ask this question: after how many weeks will they have the same amount of money? Where we're going to use X to represent how many weeks have gone by and Y to represent how much money they have. So we can write two equations here. We have Rick's equation, where he has $290 and he's getting $5 every week, and this is going to be equal to Y1, which is just the Rick's amount of money. Sophia's equation is going to be Y equals 8X plus 200, because she has $200 and she's adding 8 every week. So this is the system that we're working with here. And we want to find out how many weeks will they have the same amount of money. Well, we're set up with a system of equations again. We know that 5x is equal to 290, and 8x, or 5x plus 290, sorry, 5x plus 290 is equal to y, and 8x plus 200 is equal to y also. So we can set these equal to each other. We want these two values to be the same. When will Rick's money be the same as Sophia's money? And we're going to solve the equation to find out what the value of x has to be. So much like we did with the last system of equations, we're going to solve this system of equations by using algebra. What I did here was I subtracted 5x on both sides to get rid of this 5x. 5x is gone from the left-hand side because I subtracted it. If I subtract it on the left-hand side, I have to subtract it on the right-hand side, which is where this 3x comes from. 8x minus 5x is 3x. The 90 comes from subtracting the 200. So I'm going to subtract 200 on this side, make it go away because the 200 is gone. And if I subtract 200 on this side, I have to subtract 200 on this side. 290 minus 200 is 90. Now I have 90 equals 3x. So I'm going to divide both sides by 3 and find that x has to be 30. So what this means is that at 30 weeks, Rick and Sophia will have the same amount of money. I solved that now using algebra. I didn't have to make a list. I didn't have to make a table. I didn't have to write out all the values of how much money they'll have after so many weeks. I didn't have to guess. I used algebra to solve. 30 weeks, they will have the same amount of money by using a system of equations and solving for the variable x. Well, the next question asks how much money are they going to have at that point? After 30 weeks, how much money are they going to have? Well, we can use our equations that we wrote in the first place. Rick's amount of money is 5x plus 290. Sophia's money is 8x plus 200. Which equation do we have to use? It doesn't matter because they will have the same amount of money after 30 weeks. So if we use Rick's or Sophia's, we're going to get the same answer because they have the same amount of money at 30 weeks anyway. So if we plug in 30 into either equation, doesn't matter which one, we're going to plug in 30 because our x value is 30. What do we get out for y? We're going to plug it in and find out. I'm going to use Rick's equation. 5 times 30 plus 290. 5 times 30 is 150, and then doing 150 plus 290 is $440. So after 30 weeks, they will each have $440.